Okay, thank you for tuning in. Okay, let's come to the fourth question in the AZ104 certification catalyst series. So what is the question? Your company has a Microsoft Azure subscription. The company has data centers in Los Angeles and New York. Okay, you are configuring the two data centers as geo-clustered sites for site resiliency. You need to recommend an Azure storage redundancy option. You have the following data storage requirements. Data must be stored on multiple nodes. Data must be stored on nodes in separate geographic locations. Data can be read from the secondary location as well as from the primary location. Which of the following Azure storage redundancy options should you recommend? Okay. So here there are basically this question is relating to the storage redundancy section of Azure storage. Okay. So Azure storage offers a wide variety of redundancy options. Okay. For high availability applications, we'll go through them. So what are the options? Option is geo-redundant storage, read access geo-redundant storage, zone redundant storage, and locally redundant storage. So to answer this question, there is no way unless and until you know about the different storage redundancy options. So the best place to check for this is this article. Okay. So this is an article I have already included it in the reference section. So Azure storage redundancy, go through it. It's a 15 minutes read. It's worth it. Okay. Now, let me explain to you what are the different redundancy options. Okay. So the first redundancy option that is there is LRS, which is called local redundant storage. So what is local redundant storage? In local redundant storage, you have a data center. Okay. In a single data center, you have 3 copies of your data. So single data center, single availability zone. So it's the cheapest option of all. Okay. So as you can see, there is one data center, one availability zone, no separate availabilities are shown, copy 1, copy 2, copy 3, 3 copies. So if one copy is not there, the other 2 copies will be there. And when do we say a write is successful? When all 3 operations, so if I push a write to a storage account, it will only return a successful or as a 200 when all 3 copies have been synchronously updated. Only when all these 3 copies have been updated, I will get a kind of like a yes. Okay. So as you can see, it is the lowest cost redundancy option and it offers the least durability compared to other option. However, it protects your data against server, rack and drive failures. So within a single data center, single availability zone, it can protect against drive and rack failures. But if the zone gets destroyed, LRS gets destroyed. If the region gets destroyed, LRS gets destroyed. Okay. Now I'm coming to zone redundant storage. So if you come here in a zone redundant storage, every single it's still within a single region but across availability zones. So as you can see, within a single region there are 3 availability zones, 1 2 3. Each of them have 1 copy. Okay, so if one availability zone gets destroyed, I still have the other 2 to serve the request from, and this is also synchronous. Okay, so you can see here that a write request to a storage account that is using ZRS happens synchronously. The write operation returns successful only after the data is written to all replicas across the 3 availability zones. Okay, but here also it will not protect you against regional outages if the entire region goes out. So then you come to something called redundancy in secondary region. So here you have 2 options. First option is geo-redundant storage, GRS. What GRS does? In your primary region, you have LRS, and in your secondary region, you also have LRS. So you have data in 2 regions. So if your primary region goes down, whatever reason, maybe your region goes down completely, or your availability zone within that region where your data was stored goes down, you can always get the data from the secondary region. Okay, this is GRS. Okay, and this replication is asynchronous. So as you can see, a write operation is first committed to the primary location and replicated using LRS. The update is then replicated asynchronously to the secondary region. Okay. When data is written to the secondary location, it's also replicated within that location using LRS. What that means? It means 3 copies. But what is geo-zone redundant storage is a little better. So the further we are going away, we are getting more high availability, more durability, but at a more cost. So GZRS is a little bit different. What is the difference? That within the primary region, you have ZRS rather than LRS. So in the primary region, you have ZRS. So 3 availability zones, but in the secondary region you still have LRS, and everything else is the same. Nothing is different. So let me just show you one thing. One sec. Yes, you can see the primary difference between GRS and GZRS is how data is replicated in the primary region. Within the secondary region, data is always replicated synchronously 3 times using LRS. So nothing changes in the secondary region. Okay. So this is GRS. Now, what is the problem with all of this is that at one point of time, you can only access the primary region. You cannot access your data in the secondary region. With GRS or ZGRS, you cannot access the data in the secondary region unless and until you initiate a failover to the secondary region, or Microsoft initiates a failover if the primary region is unavailable. But say I want to access my primary region and secondary region simultaneously. In that case, I have read access geo-redundant storage. So I will show you this. So see, it is written, if the data is available to be read only if the customer or Microsoft initiates a failover from the primary to the secondary region. When you enable read access to the secondary region, this is the RA option, your data is available to be read at all times. So this is what is the best option, RA-GRS or RA-ZGRS. Okay. So here everything is the same as GRS or GZRS, only RA, meaning you have read access to both. So how will you access the secondary? That is very easy. I will show you that also. When read access to the secondary is enabled, your application can be read from the secondary endpoint as well as from the primary endpoint. Primary endpoint means primary region, secondary endpoint means secondary region. The secondary endpoint appends the suffix secondary to the account name. For example, if your primary endpoint for blob storage is myaccount.blob.code.windows.net, secondary endpoint is myaccount-secondary.blob.code.windows.net. So this is the main thing. So we have LRS, we have ZRS, we have GRS, we have GZRS, we have RAGRS, we have RAGZRS. Now let us come back to the question. So here it is written, data must be stored on nodes in separate geographic locations. So we need geo-redundancy. So LRS goes out because LRS doesn't offer you geo-redundancy, and ZRS goes out because ZRS doesn't offer you geo-redundancy. So you have A and B. Now within A and B there is another thing. Data can be read from the secondary location as well as from the primary location. So this is only possible for read access geo-redundant storage. With only geo-redundant storage, you cannot access data from both primary and secondary at the same time. Okay, so this is the most important thing, that you need to understand the difference between RAGRS and GRS, or RAZGRS and ZGRS. So here the correct answer is B, read access geo-redundant storage is a reference. But before I go, I would like to again focus on a few very important facts from this documentation. Okay, so first very important thing that you need to see here, I will show you. See, the archive tier is not currently supported for ZRS accounts. So zone redundant storage doesn't support archive tier, very important. Another thing, storage accounts that contain Azure managed disk for virtual machines. So as you know, when you have a virtual machine and you use the Azure managed disk feature, then the actual VHDs are stored in storage accounts which are managed by Azure only. They always use LRS. Azure managed unmanaged disk should also use LRS, even if you use Azure unmanaged disk. What it is saying, it is possible to create a storage account for Azure unmanaged disk that use GRS, meaning global redundant storage, but it is not recommended due to potential issues with consistency over asynchronous geo replication, because the replication is asynchronous, right? Within regions, within a region, okay, meaning say in region 1, it is always synchronous. Whether it is within a single availability zone or 3 availability zones, is always synchronous. But across region, it is always asynchronous. Another very important, neither managed nor unmanaged disk support GZRS or ZRS. So it is very important. So zone redundancy, so the Azure managed disk feature that we have, it's always LRS. It is not ZRS, it is not GRS, it is not GZRS, it is not RAGRS, RAGZ, nothing. Okay, this is very important. Another thing which is very important, I want to show you here. See, because data is replicated to the secondary region asynchronously, this is case of GRS or RAGRS or GZRS or RAGZRS. This is that case, meaning regional redundancy. A failure that affects the primary region may result in data loss if the primary region cannot be recovered. The interval between the most recent writes to the primary region and the last write to the secondary region is known as the recovery point objective. The RPO indicates the point in time to which data can be recovered. So the which data from the primary region is actually recovered in the secondary region. Azure storage typically has an RPO of less than 15 minutes, although there's currently no SLA on how long it takes to replicate data to the secondary. It's very important to mention to your client. There is no SLA on the RPO. So it can happen, for example, that you have enabled GRS or RGRS, okay, or RGZRS, whatever. But when the actual failure happened, okay, you do not have data for even 1 hour because there is no SLA for that. Typically, it is less than 15 minutes because replication is happening, but it can even go beyond that. It's very important to note. There is no SLA as such from Microsoft that any data before 15 minutes of the failure will be surely replicated. No, there is no such SLA. So how do you know which has been replicated, which has not been replicated, which is very important. So here it is last sync time property. So what it is written, because data is replicated to the secondary region asynchronously, the secondary region is often behind the primary region. If a failure happens in the primary region, it is likely that all writes to the primary will not yet have been replicated to the secondary. To determine which write operations have been replicated to the secondary region, your application can check the last sync time property of your storage account. Every storage account will have that property. For storage accounts which are geo-redundant kind of, okay, either GRS or GZRS or RGRS or RGZRS, okay. All write operations which are written to the primary region prior to the last sync have been successfully replicated to the secondary region, meaning that they're available to be read from secondary. Any write operations which are written to the primary region after the last sync time may or may not have been replicated to the secondary region, meaning that they may not be available for read operations. Very important. Okay. So here the last sync time can even be 1 hour before because there is no SLA. Okay, so it's very important to understand. But we still need to check the last sync time to understand the RPO. Mostly the last sync time will be less than 15 minutes. So you can consider a rough RPO of 15 minutes. Now another thing I want to discuss before ending. See, Azure files do not support read access, geo-redundant or GZRS. So it does not support read access, meaning this is very important. Okay, so what is the difference between GRS and RGRS? Many people fail to understand this. In both cases, your data is replicated in the primary region from the primary region to the secondary region. So let us consider GRS. So your data has three is in LRS in the primary region and also in LRS in a secondary region. Very good. Now, say for example, I want to access my data in the secondary region. For GRS, I cannot do that unless and until I initiate a failover or Microsoft initiates a failover to the secondary region. Okay. But in case of RGRS, my secondary region is also available. Okay, so I can always try to access data from my secondary region also. In case, say, for example, for some reason my primary region is not available, even before, without initiating a failover, whether it's a customer initiated failover or Microsoft initiated failover, I can do that. This one, another I will show, very important. Yes, see. With ZRS, your data is still available for both read and write operations, even if a zone becomes unavailable, because it's zone redundant. I have data in 3 availability zones. If a zone becomes unavailable, Azure undertakes the networking updates, such as DNS repointing. These updates may affect your application if you access the data before the updates have been completed. Say your availability zone 1 has been destroyed. You're still trying to access the data. So Azure will take some time to point the DNS to the new availability zone data, right? So when designing applications for ZRS, follow best practices for transient fault handling, including implementing retry policies with an exponential backoff. It is very important. Okay, you have to have this kind of redundancy even in your client code. Otherwise, in the time in the backend Azure is moving the DNS or pointing them to the other availability zone or something like that, and your code will return an error because it's unavailable to access the data, even if you have ZRS, which should not be. Okay. Another thing I will show you. Okay, see here. Microsoft recommendation is using ZRS in the primary region for scenarios that requires high availability. Okay, so for primary region, if you are not concerned about regional redundancy, always go for ZRS. Okay, that is the most important thing. And for Microsoft recommendation for multi-region will be GZRS. Okay, so that is okay. Another thing I will show you. Yeah, see. When you create a storage account, you select the primary region for the account. The paired region or the secondary region is determined based on the primary region and it cannot be changed. This is very important. So you cannot say that my primary region is East Asia and my secondary region will be East US. No, it will always be Southeast Asia because those are paired regions. Okay, this is very important. I wanted to show you. Another thing I would like to show you once again. Yes, this is very important. Only general purpose V2 storage accounts support GZRS and RAGZRS. This is very important. Okay, only general purpose V2. One second, another thing I wanted to show. Yeah, see. If your storage account is configured for read access to the secondary region, meaning RAGRS or RAGZRS, you can design your applications to seamlessly shift to reading from data from the secondary region if the primary region becomes unavailable for any reason. The secondary region is available for read access after you enable RAGRS or RAGZRS so that you can test your applications in advance to make sure that it will properly read from the secondary in the event of an outage. So here comes the suffix secondary. So this is basically it. You can go through more of this. This document entirely is a very good document to understand Azure storage redundancy. I have gone over it maybe 5 to 6 times over my career of 4 to 5 years in the cloud. Okay. So thank you guys. Take care.